Welcome to ASCII Geek.
Hey, if we haven't met already, I'm the digital avatar of ASCII Geek,
where we build your next advantage with tomorrow's technology. And today, one of our experts is stepping in to show our latest breakthrough. Enjoy and happy learning.
All right. Most developers start with Claude by plugging straight into Anthropic's native API. It makes sense for prototypes, but as your project scales, that default choice becomes a strategic trap. To understand why, you must look at the physics of your data. There is a principle in systems architecture called data gravity. It means that massive enterprise datasets act like physical anchors. Because of their sheer size, you cannot easily move them. Instead, your compute processes have to orbit around where that data already lives. If you ignore this and pull terabytes of proprietary data out of your native cloud to send it to Anthropic servers, the immediate financial result is thousands of dollars in external egress fees every month. You also get hit with a severe performance penalty. Moving heavy datasets across external network boundaries just to reach a frontier model adds noticeable latency to every single operation. Engineers usually tolerate this because the native API grants them day-one access to the newest features. Right now, that means getting hands-on with Claude's massive 1 million token context window before anyone else. But choosing your API endpoint is an infrastructure decision, not a developer preference. The route dictates your long-term costs, your network latency, and your compliance posture. We see this play out constantly. A high-scale prototype works flawlessly on a developer's local machine, and then completely collapses the moment it faces real enterprise production loads. Single-vendor APIs use token buckets. When demand spikes, your app gets slammed with 429 rate limit errors. Quota limits choke throughput, causing data requests to bottleneck and pile up. Teams are forced to build complex Redis-backed rate limiters just to meter out the traffic. Cloud hyperscalers exist specifically to handle this kind of chaos, offering engineered resilience out of the box so you don't have to build custom traffic cops. If you build an AI tool without anticipating these production rate limits, your software prototype becomes a fragile infrastructure liability. Let's look at the options, starting with the Anthropic native API. Its absolute biggest advantage is speed. You get the fastest possible access to day-one features and the newest model versions. A prime example is prompt caching. This native feature allows you to store frequently used context on Anthropic servers, which cuts the cost of processing that repeated context by up to 90%. For applications that process entire codebases over and over, that cache read discount translates into significant monthly savings. There is also the Batch API, which processes non-urgent, asynchronous workloads within 24 hours. Routing bulk tasks through this cuts your token costs in half. But there is a heavy trade-off. Renative API shifts the burden of network security and traffic routing entirely onto your engineering team. This leaves your system fully exposed to single-vendor rate limits. If you hit your global quota, your service stops. The native API is the right choice only for teams where rapid feature velocity strictly outranks the need for managed infrastructure. For data-intensive, analytics-driven pipelines, Google Vertex AI offers a highly engineered alternative. If your organization's massive datasets already live in Google BigQuery, accessing Claude through Vertex AI gives you a massive architectural advantage. The model goes to the data, rather than the data going to the model. By executing models directly within your analytics stack, you eliminate cross-system data transfers. That zero data movement approach wipes out external egress fees. It also provides military-grade security. Operating Claude through Vertex AI keeps your workloads within a FedRAMP high authorization context. To get this level of security, your company has to implement rigorous Google Cloud governance, and you have to accept that new Anthropic features will take a little longer to show up on the platform. But for large data ecosystems, Vertex AI is the superior choice to turn records into secure AI assets without bleeding your budget on data transit. Finally, there is AWS Bedrock, which is built for organizations already invested in the Amazon ecosystem that require absolute maximum uptime. Bedrock's core benefit is infrastructure-wide agility. It connects you to multiple AI vendors through a single API connection. If your application hits a rate limit on Claude, Bedrock instantly reroutes the prompt to an Amazon Nova or Llama model. For even more reliability, Bedrock offers provisioned throughput, a guaranteed, dedicated capacity pipe that bypasses shared rate limits entirely. The strategic trade-off here is pricing. You sacrifice the flexibility of paying only for what you use, exchanging it for fixed, predictable capacity costs that guarantee your required tokens per minute. By abstracting away the infrastructure complexity and guaranteeing uptime, AWS Bedrock becomes the safest choice for enterprise-embedded, mission-critical AI. To map your specific infrastructure to the correct API endpoint, the team at Xenos developed a straightforward decision framework. Rule 1. Use the Anthropic native API strictly for multi-cloud or hybrid infrastructures, where having day-one feature access and advanced prompt caching are your highest priorities. Rule 2. Route through Google Vertex AI, specifically if you operate data-heavy pipelines and want to leverage your existing BigQuery datasets without incurring egress fees. Rule 3. Choose AWS Bedrock for organizations requiring guaranteed high availability, multi-model resilience, and deep integration with current AWS workflows. Successfully scaling enterprise AI relies on aligning your API endpoint with the physical location of your core data. Once you have chosen your endpoint, your next step is securing it. Click on our next video to learn how to properly rotate and protect your API keys to keep your infrastructure safe.
All right, that's the update from the lab for today. I hope you learned something new. Head over to ASCIIgeek.com